Hello and welcome to this section of the MATLAB tutor. Here we're going to learn how to solve algebraic equations symbolically. So we're going to use the symbolic aspects of MATLAB, and I have to say they're very useful and very commonly used. So definitely pay attention to this and you'll unlock the power of what MATLAB can really do. Up until now we've learned how to solve single equations and we've learned how to solve systems of equations, but we were always doing that in the default method of MATLAB's workspace, which is sort of numerically. In order to do things symbolically, where you're actually asking it to rearrange algebraic expressions, we already talked about this, but you need to be using these symbolic variables. So for instance, if I want to solve an equation for x symbolically, in other words, keeping it as exact and perfect algebraically as I can, then I need to declare a symbolic variable x. For instance. So I go ahead and do sims x, and you can see the variable pop over here, and it tells you it's a symbol. So it's a special variable that it can use algebraic rules on. So now we're exiting the realm of numeric approximations, and we're into the realm of algebraic perfect, right? So if I want to solve a simple equation, just to kind of give you the idea of how this works, then what I'll do is I'll do solve, which is a new command that we haven't used so far. So solve, open parentheses. The equation needs to be encapsulated in a single quote like this. So just to kind of get the hang of it, x plus 3 is equal to 2. Something that everyone can do in their head. So x plus 3 is equal to 2. And now you have to tell MATLAB what variable do I want to solve for. So you put comma x. This is the command syntax for the solve command. Now the variable in the equation here has to be symbolic, so you have to have declared x as a symbol first. So we go ahead and do that. MATLAB is not numerically approximating it. It is actually using the rules of algebra to take the 3, subtract it from both sides, and you get -1 for the answer. So it's isolating the variable x. That is why we're typing in the full equation in terms of x and not just giving it a matrix of coefficients like we were doing before. Because before we were doing sort of approximations and you were getting decimal answers all the time. Here we're getting algebraic perfection. And let me just show you real quick what happens. Let me pull the last command back up. Let me change this to y, and we're going to solve for y. Notice I have not declared y as any kind of symbol. I'm just going to say I forget to do that. If I type that in, MATLAB's going to say we have an undefined variable or function y. It just doesn't work unless you defined it as a symbol. So now that it's a symbol, and you can see it in the symbol workspace over here, I'll pull up that same exact guy, and you can see that y is equal to -1 because it's solving for y. All right. So you can have quite complicated equations, and MATLAB will really do its best to keep everything perfectly exact as it can. So for instance, if you have x squared plus 2x minus 3 is equal to 12, this is the type of problem we were doing in the last section, or in the last couple of sections, where we were solving it with the roots command. But here we're typing the full equation in, including the x's and everything else. So x squared plus 2x minus 3 is equal to 12, and we're solving this equation for x, so we have to tell it that, and MATLAB will go and calculate that, and it will give us exact answers. Notice there's no decimals here, there's no approximation. It's trying to keep everything perfectly exact here. So it's moving the 12 over, it's able to factor it perfectly, and so on. And if you change one of these guys to something that's a little harder, then MATLAB, in this case, you can see we just changed it to something that wasn't easily factorable. MATLAB still, again, tries to keep everything exact. It's not giving us decimal answers. It's keeping it exact. It's the square root of 15 minus 1, and it's negative square root of 15, or square root of 15 with a -1 out in front, and then also -1. So we get the same two answers as we would get in a calculator. It's just that it's keeping it totally exact, and that's what the symbolic toolbox in MATLAB is always going to try to do. If you have a hard time reading this, or if you're like, okay, that's great that it's exact, but I don't know what that means, I don't know what number that's equal to, then just pass it to the double command, the last answer, make it into a double, and that tells MATLAB to turn that last answer into decimals. So this top answer is equal to this, and the bottom answer is equal to that. But when you're using these symbolic variables, MATLAB is always going to try to keep it perfectly exact. To give you another example of that, what if you're going to do solve, remember x and y are our symbolic variables, let's solve something like sine of x is equal to 3, right? And we're going to solve for x. So what we're really asking MATLAB to do is we have this equation, sine of x is equal to 3, and notice this is not a straight up algebraic equation that's easily solvable like with roots or factoring or anything like this. This is a trigonometric equation. So MATLAB is going to do the best that it can to give you a totally exact answer. And so it'll give you an exact answer. In fact, we have arcsine of 3 and we have pi minus arcsine of 3. And if you notice in this case, what's really happened here is when it tried to solve this equation, the only thing it can do, since you're trying to solve for x, is it's trying to take the arcsine of 3, but there isn't really a way to give you an approximate answer other than to tell you that it's just the arcsine of 3 and it's pi minus that. So if you want to convert that to decimal, those answers, as always, you can just convert those last answers to decimals, and you can see the problem here. You get complex answers in here. And in fact, you can see why you get a complex answer, because the sine function, the function of the sine, of a sine wave, so to speak, can only go up to plus or minus 1. So here we gave it an equation where we're outside of that region, so the answers that you get are complex, right? So if you wanted to do that again and give it kind of a more reasonable thing, let's do something like 1/2, like this, okay? And the answers that we're going to get when you have sine of x is equal to 1/2, it'll go and calculate pi over 6, 5 pi over 6, and give you some real answers. And it'll give you in an exact form that, again, you can always convert to numbers if you need to. So pretty much, I mean, you can type any equation you want into MATLAB in the Symbolic Math Toolbox, and it will do its best to solve it for you in an exact way. So for instance, so far we've had one variable like x or y in our equation, but you can actually have multiple variables. So right now we have x as a symbol variable and we have y as a symbol variable over here. Let's go ahead and just add z as a third symbol variable. Let me clear the screen. So x, y, and z are just symbol variables, right? They're just generic symbols that can be used to put in algebraic expressions. Now let's do something a little different. Let's say we have solve, and what I want to do is make another type of equation here. Let's do x plus 2y is equal to negative 3z. Now what we're going to do here is let's solve this for y. All right. So here's our syntax. X plus 2y is equal to negative 3z, and we're going to solve it for y. Notice that x, y, and z have no values. They don't have any numbers associated with them. We're just basically solving this equation for a variable algebraically. And you can see that when you do that, y is equal to this stuff right here. So it's doing the rules of algebra to manipulate the expression to return what you want. And if you don't like the way this looks, I mean, obviously this is not a number, but it's kind of hard to visualize with the fractions everywhere. You can always use the pretty command to make it a little more readable. So it's negative x over 2 minus 3z over 2, and that is just a straight simplification of what we have by the rules of algebra isolating y over here. And we can do the exact same guy isolating for x, take the exact same equation, isolate for x, and we'll get this. And of course we can take the exact same equation and isolate for z and get the same thing. So you don't always have to use the solve command, I guess is what I'm trying to say. You don't always have to use it to solve for equations to get numerical answers. You can use the solve function in the Symbolic Math Toolbox simply to manipulate expressions algebraically. You may have a very large expression to solve for x, and you might need to algebraically move things to the left and the right hand side. MATLAB can do all that stuff in the Symbolic Math Toolbox. So as one final example, let's say we're going to have solve of sine of x plus e to the power of z. That's what that is. And let's do plus 3 times y. Let's make it equal 3 times y. So this is an equation. It's kind of complicated because we have the x variable wrapped up in a sine, we have the z variable wrapped up in an exponential e to the power of z, and then we have y over here. Now if we solve it for y, it's pretty simple because y is already over here, so we just divide by 3, and MATLAB can take everything and basically divide by 3 and isolate for y. Now if we want to take this one step further, I have the equation in here again, instead of solving for y like we did before, we can solve for x. Now x is wrapped up inside of this sine function here, so whenever I solve for x, it's going to look a little more complicated, and you can see some arc signs pop up here, and that's because to solve for x, you have to move this exponential to the right hand side and then take the inverse sign. That's what we have here. Now MATLAB's giving us two answers because, you know, there's usually multiple answers when you do an arc sign. Usually they're spaced apart by pi, and so that's what it's basically done here. But again, it's doing the algebraic work for you. And then finally, we can solve this for z, this exact same expression for z, in which case MATLAB is going to return a natural logarithm, basically, because you move the sign over to the other side, and then to get z by itself, you'll be taking the log of both sides. So in summary, that's really how you use the symbolic solver with the symbolic math toolbox. You can solve very simple equations, you can solve polynomials, you can solve more complicated equations and get exact answers and then convert them to decimals with the double command. And those are nice things when you're trying to find numbers as answers. Or if you're just trying to manipulate an expression, you can dump it into the same exact solve command, and as long as everything and every variable is defined symbolically, you can solve for any variable you like. So in terms of symbolic math, MATLAB is really cool because you don't have to memorize a million different commands. I mean, there's a solve command. You dump it in there, as long as it's symbolic, it's going to be able to do its work. So in many cases, this would be the first place that you'd go if you're just trying to solve a generic equation. You don't want to really think too hard about how to put it in here. You just want to get it in there and get the answer. This is usually how I would tackle it because it's the easiest and closest to what you would probably do on your paper. So get in here, learn how to define your variables symbolically to get them in the symbolic workspace. Put them in single quotes and tell MATLAB what variable you're solving for, and it will do the heavy lifting for you.